Hello again, everybody. Gonna make the second Matlab tutorial video. This video is going to cover plotting, for loops, and if statements. I think all these things are good to know in general for Matlab and should help you with the homework as well. I also saw that you had homework in your math class that involved plotting, and it's kind of similar to what you're expected to do on the homework for biomechanics. So hopefully this tutorial will help you out with both of those classes. So let's get started. The first thing I'll do is go through if statements. So I'll demonstrate how they work by making a function file, which you should be familiar with from the last homework and the last tutorial video. And basically what we'll make this function file do is check to see if whatever number you input is greater than 4, equal to 4, or less than 4. And we'll do that using an if statement. So here's how that would look. So we'll say it's a function, and we don't need an output. We'll just print to the command window whether or not the number that you've input is greater than, less than, or equal to 4. We'll see how that works later on in writing the code. So let's call the function is greater than 4. And the input argument will be x, which will just be a number. And this entire function is just going to consist of what we write in the if statement. So what we'll start is we'll say if x is greater than 4, or greater than 4. So if that's the case, then we want to display to the command window x is greater than 4. On the other hand, the other possibility is that x could be equal to 4. Now, if you're checking to see if something is equal to something, you need to put these two equal signs. One equal sign is only used for when you're defining variables as something. So if you were to say something like a equals 3, then that's when you'd use one equal sign. If you said, let's say we wanted to define b as 4, if you did b equals 4, Matlab doesn't know what you wanted to do. But if you wanted to check to see if our a variable was indeed equal to 3, then you could say a equals 3, and it should return 1, meaning true. So there you go. So back to our function, we're going to check to see if our input argument x is equal to 4, and if it is, then we'll display x is equal to 4. And then else, which handles the case where x is not greater than 4 and x is not equal to 4, which only leaves x is less than 4, then we display x is less than 4. And we end to conclude the if statement, and then we end again to conclude the function file. And we'll save that, and remember that when you save function files, you want to have the file name match the name of your function. So Matlab does that automatically for you. So we'll just call it is greater than 4. And you can see it's saved over here. Now, when we use this function in the command window, and let's say we want our x value to be 12, which is greater than 4, so our function should return x is greater than 4. And there you go. Now if you want to check to see what happens when we put in 4, x is equal to 4, and for something less than 4, it says that it's less than 4. So yeah, I think that's pretty straightforward. Think of if statements as if you were, just speaking regular English. So you're saying if x is greater than 4, then do this. Else if x is equal to 4, then do this. And else handles every other condition. So yeah, it doesn't matter which order you do these in. So for example, we could have the x equals 4 be the first thing, and the x greater than 4 be the second thing, and then, switch these around. and save it, and it should still work. So let's test the equals for. There you go. So yeah, it doesn't matter which order you do them in. I think this is pretty straightforward. If you have any questions, email me, leave a comment, and I'll do my best to answer those questions. Yeah, okay. So next concept is plotting. Let's cover some plotting commands in Matlab. So first thing we'll do is generate some data. So let's say our x data is from, say, negative 100 to positive 100, and that'll go in increments of 1. This notation should be familiar to you from the homework in the last tutorial video, but just to recap, if we define x like this, it'll make x a vector from negative 100 to positive 100, and it'll go in increments of 1, so it'll go negative 100, negative 99, negative 98, all the way up to 100, and it'll save it as a vector. So this is what the variable looks like if we open it from our workspace, and there you go. You can see all the values. Now let's say that y equals, just say x squared. So remember that this notation where you put the period before the caret to indicate that you're squaring the vector means that you only want it to square every element individually. So this distinguishes performing a function on each element of the vector or matrix that you're using that you're raising to the second power. It's that versus just regular matrix multiplication. So if you were to do x squared, it can't do it because you can't square non-square matrices. Just think back to, you should have learned this in some kind of like linear algebra math course or section of a math course, just matrix multiplication. So using x squared or even x times x, it's going to try to do your typical matrix multiplication, which you can't do unless the matrices or vectors that you're using are appropriately sized. Whereas if you do the x period times x, which is the same as x period raised to the second power, it'll just do x squared on each individual element of your x vector. Okay, so now we have our x and y data. Now let's plot them. So the simplest plot command is just plot, and you can do just plot y, and it'll plot it. It'll plot your y values, and for the x values, it'll just do it from 1 to however many y values you have. So you can see this isn't the curve x squared because the vertex is at 100 when it should be at 0. So to make this curve correct, kind of the way that you'd expect, you want to put your x data, then your y data, click enter, and now it's centered about 0. So yeah, that's pretty good, but we need to label our axes, right? So the way that you do that is you do x label, and then in apostrophes you put whatever you want to call your x-axis. So let's say our x-axis in this case is time in seconds, right? And if we go back to our figure, now you can see right here our x-axis is labeled as time. This might be somewhat of a review. I used some of this code in the homework 1 assignment that I gave you. So if you look through it and learned it then this is just review and you can skip this part of the video. But if you didn't look over that, or if you didn't understand it, then hopefully this clears some things up. So to label the y-axis, it's a similar command, just y label instead of x label. And let's say y is, I don't know, position in meters, let's say. And now the y-axis is labeled. You can also give a title to your plot, which again is a pretty straightforward command. It's just title, and we'll call it position versus time. And there you go. Um, so yeah, that's I think some of the most basic plotting functions. So that's that. Now to get into some more complicated plotting things. I'm gonna start writing in a script file just so I don't have to keep rewriting in the command window. So let me go back to Xdata that I made. Oh, so a nifty trick in the command window is if you push up, the up arrow key, it'll cycle through the previous things you've typed in the command window, which can be useful so you don't have to keep typing over and over again the same thing if you're trying stuff out. Or if you start with like the first letter, so let's say P, and then push up, it'll take you to the last thing that you did that started with the letter P. So it should take us back to the plot XY line. And if we do it again, it'll do plot Y, and we'll just stick to everything that we've written with P as the first letter. And you can do that with any letter. So Y should take us to Y label, and then there you go. So nifty thing just to, keep yourself from retyping the same thing over and over again. So here is my line where I define the X data. I'll just copy that into the script. And then Y data was X squared. And let's rewrite our plotting commands. So we got plot X comma Y, and our labels. Oops. Okay. So, let's say we have this plot, but we want to plot another function besides y equals x squared. Let's say we want to do y equals x to the third, right? So let's call this y2 equals x to the third power. And we want to show them on the same graph. So if we do that, let me go back to the command window. Or no, I closed the figure. Okay, so let me save this. Plotting tutorial, let's call it. Okay. So let me run this, and there's our plot that we got from before. Now let's say I wanted to plot this y2 equals x to the third power. So if I just type in plot x y2, it completely overwrites the plot that we just made that was y equals x squared. But we want to have both on the same graph, so it's easier to directly compare the two. So the way that you do that is by using this hold on command. So let me replot the original data, and now let's say hold on. So this is going to say to Matlab, put the plot on hold, basically. That means don't overwrite it even if I tell you to plot something else. So we've plot y equals x squared, and now we want to plot y2 equals x cubed on the same graph. So we did hold on, and then we did the plot command like how we did before, and now you can see them overlaid on top of each other. It's kind of cruddy because the y cubed completely overwhelms the x squared, but that might be a good opportunity to show you another plotting command. So instead of using normal plot, you can give the plot log axes, right? So the command for that is semi-log x or y. So in this case, our y-axis was kind of had some pretty big values. So let's try to make the y-axis a log scale. So if we do semi-log y, x comma y, we get that. Looks kind of funky. And then we do hold on, so that when we plot the next thing, it won't overwrite the first thing. And then let's see what it looks like. Right, so I guess it's going to ignore the negative data because of the way logs work. So we only get the positive data for the x cubed graph, but now we can see them both on the same chart. So it's up to you, if you were making this graph for an assignment or, for a research project or something, whether or not that'd be appropriate. But at least this way you can kind of get both of the graphs so you can actually see their shapes in the same graph. So let's just kind of roll with this. And you can do this indefinitely. So once you've typed hold on, now you can plot x to the fourth, like this. And you get the other graph. You can do it again for x to the fifth, x to the sixth, and so on. But you can see if you have a whole bunch of graphs like this on top of each other, at some point it's going to get difficult to distinguish which one is which. So when that happens, it'll be important for you to change the color of the line that's plotted. So you want to use like different line colors for different lines, for different functions. And then you want to provide a legend that tells whoever's looking at it, which line is which. So I'll show you how to do that next. Right. So let's come back down here and add some more plots so we don't have to keep retyping this over and over again. So we'll do hold on, plot x, y2, and then we can do plot x to the fourth, x to the fifth. Okay. Oh, and let's change our plots to semi-log-wise so we can visualize all of them at the same time. Okay. So once we've done that, we need to add a command to the semi-log y to make each line a different color. Now for me, I usually forget how to make things different color, so every time I use the plotting command, I have to Google what the syntax is for changing the colors. So I'd just Google Matlab plot, and it's the first result, 2D line plot, and there we go. And you can see all the other similar plotting commands over here on the left. So you can do log, semi-log x, semi-log y. Some of these other plots get a little bit more complicated, and it depends on what you're trying to plot. But this website, this mathworks.com help website, is a valuable resource. I can say that I know MATLAB all I want, but I always have a tab from this website for the functions that I'm using. I always have this website open because there's no real point in remembering the nitty-gritty details of all these functions if you can just pull it up really easily. Alternative, instead of using the website, you can just type in help plot, and it'll bring it up in the command window like this. But this isn't as nicely formatted, and it's this weird notepad style text. So I prefer the website, but you can do it in MATLAB too. If you don't, I think it'll work in the MATLAB command window even if you don't have an internet connection. So that might be valuable if you were working offline for some reason. But anyway, so we want to try to change the color of our plot. So we go in here and we can see, this is the functionality that we're familiar with. Semi-log y, semi-log x1, y1. It'll plot, those things. But to change the way the line looks, we need to know these line specs, right? So we need to say, this is the line specification that I want to change, and then this is what I want to change it to. So it's also this represented as this property name and then property value kind of a thing. So we can look at the chart line properties, and it'll show us all the things we can adjust. So we can adjust the style of a line, so whether it's a solid, a dashed with some periods in it. It shows you what those look like. We can change the width of the line, we can change the color, all sorts of things. We can change the marker, so we can make the markers little circles or plus signs, X's, whatever we want, we can change it to. So for right now, let's just focus on color, and let's just use the first. How many plots do we have? We have 1, 2, 3, 4. So let's just use the first four colors: the yellow, magenta, cyan, and red. So all we have to do is say semilog y, and then after we've given it the data that we want it to plot, we put color and yellow, and then color and magenta. You can also do, instead of typing out the entire name of the color, you can do this one letter abbreviation. And then back to our first one, like this, and red, like that. So now, let me clear the workspace. If we run this, we get a bunch of different colors. We still don't know which one's which, so we need to add a legend. So the way that you do that is just by typing legend, and then we have 4 lines, so we need to give it 4 names. So let's say x squared, x cubed, x to the 4th, and x to the 5th. Right, so you just list the names of the lines in the order that you plotted them in, right? So we plotted x squared first, then y cubed, then x cubed, then x to the 4th, x to the 5th. So if we do that and click enter, come back here, we can see that our graph has a legend now. The legend kind of gets in the way of the lines. It's not a big deal for this. There are commands to move that around if you want. So I don't know this off the top of my head. So again, I'd Google, Matlab legend. Come over here, go to the help page, and there's a bunch of commands. So this one looks promising, orientation and value. So let's check out the example that it gives. And there you go. So it tells us there's actually a location and an orientation. So I guess the orientation would put all of the, each thing in the legend. It'll arrange it horizontally as opposed to vertically, like how ours is vertically. And the location is north outside. So maybe it's just because I'm familiar with Matlab, but it seems pretty obvious to me by checking out that this is the location and it says north outside, and by checking out the figure that it provides, north means it's on top of the graph, and outside means that it's actually outside of the plotted area. So if we go back to our command window and we say legend like that, and we type in location, and we do north outside, we can go back to our figure, and there you go. But it does kind of look ugly if it's stacked on top of one another like that. So let's try adding that orientation. And I think it just said horizontal, right? Yeah. So we look again, and there you go. Our graph is much more readable now. So yeah, so let's try, instead of just changing the color, let's try changing what the marker looks like for the graph. So if we come back to our plotting, this is our chart line properties. So if we change the marker, let's change 1 to circles, 1 to pluses, and 1 to x's. So marker is the property that we want to change. So let's get rid of this. And instead of color, we're going to have marker, and this one's going to be marker and plus sign. This one will be an X, and we'll leave the other one as a solid line, our first one right here. And we'll leave it as a red line too. And let me also copy this legend command into our script, so I don't have to type it manually each time. And let's run it. There you go. So now you can see the lines are even more distinguishable, even though these are all blue. So maybe we should have kept the colors in there. So, but yeah, you can see, this one's a plus sign. This one's this is the same line. So they're both plus signs. This one is X's, this one's circles, and then this one's a solid red line. So let's go back and add color again. So this one, let's say, is green, and this one we'll make black, and this one will be blue. One last time. There you go. Now the lines are really easy to distinguish, and our legend is much more clear. So yeah, I think this is pretty much the most you could expect out of Matlab's plotting stuff. Oh, one last thing. So because it can kind of get messy to look at, and if you have so many plots, it can be a lot to type. Instead of doing marker 0, color green, marker plus, color black like that, you can include it all in one command. So instead of doing all these individual things, you can write it how it's written right here. So you can see they have like plot x, y1, and then they have this dash r0. So this is going to be a red line with zeros as the markers, and that's what this is. And this one's going to be a blue line with dashes and points as the markers, and you can see that's what that blue line is, right? It's dash, point, and it's blue. This one is again dash red red circles for the markers, right? So instead, let's try that. Let's do red circle, blue like that. Let's try a plus, right? Plus green maybe, and we can leave that as a solid red line. So yeah, so it's all the shorthand notation, right? So it's red is just R, blue is just B, green is G, and you just include the marker in there like that. So if we run it, there we go. Now we can get the same or similar kind of result without typing in color and marker in each plot command, which is more concise and makes the code easier to look at. So again, there's a bunch of options for how you plot things specifically. If you're not sure of what the specific command is, I mean, you can find it in these MATLAB help pages. If you just go to plotting and then go to like chart line properties, it'll tell you every single property you can change in a plot. And the way that you do that, if you want to do it one by one, is by doing that. You can either do it the shorthand way, or you can type in individually, marker like this, plus sign, color, and so on, right? So now that we have that, I'll get into for loops, right? So for loops kind of seem to be the first thing, or the first like kind of programming concept that gives people a lot of trouble. I know I didn't really get them until I kind of was forced to have to code, and I had to use for loops. And it's a really simple idea once you get it, but it kind of takes some practice to be comfortable with them. So let's do a simple example. Let me think. Yeah. Okay. So let's try plotting kind of these same things, but instead of typing each plot out individually like this, we'll try to do it in a for loop. So I'll make a new script, and we'll start it off with a for loop, right? So the kind of general format of a for loop is you're going to say for, and then you're going to prescribe a variable. I'll call this the looping variable. So this is our looping variable is just going to be a. It can be anything, A, B, C, D. It can be a word. It can be yellow. Again, it can be cats are my favorite animal, but I recommend you keep it short because you're going to type it repeatedly throughout your for loop probably. So let's just use a, and you're going to set a equal to essentially a vector, right? So let's do a from 1 to 5, right? So this is the start of a for loop, and then you're going to have some juice, some important part of your for loop, and then you're going to end it. So let's write the body. So what we want to do is plot x squared, x cubed, x to the fourth, x to the fifth, without having to type it out individually each time. Let's bring our x data in here into our for loop code, and let's make a y variable, right? So we're going to do the same thing. We're going to do y equals x to the a power, okay? So what it's going to do is it'll go through the for loop 5 times, right? It'll go through the for loop where a equals 1 and do whatever you say, and then it'll start back up here and do a equals 2, then a equals 3, then a equals 4, then a equals 5. So it's going to do whatever it is you put in here for each number that you tell it to at the beginning of your for loop, right? So what this is going to do is it's going to do y equals x, which we just define up here, to the a power. So it's going to do x to the first power, x to the second power, x to the third power, x to the fourth power, then x to the fifth power, right? Which is basically what we did here when we typed it in manually, x to the fourth, x to the fifth, x cubed, x squared, and then we skipped x to the first power, but we'll include it with our for loop. If you didn't want to include it, you could just change it from 1 to 5 to 2 to 5, right? Then it would start with x to the second power, but it doesn't matter. And you can do negative numbers in here. You can do negative 100 if you wanted, but let's just keep it simple and do from 1 to 5. So it's gonna make our y equation, and then we want to plot it, right? So we'll say plot x, y. Oh, but I forgot. Let's do our semi-log y so they all look nice. It's y. And then we're gonna want a way to differentiate the lines. So there might be other ways of doing this, but I think the easiest way to do it is just to make the line a random color. And I don't remember off the top of my head how to do that, so I'll Google it, and it might lead me down some paths that are not ideal, but let's struggle through this together just so you can see kind of how I'm thinking about problems when I'm working through Matlab. Right, so this doesn't seem to be what I want, right? It's giving me like 3D plots, like crazy pixels. So this doesn't look very promising. A lot of times, this is a very helpful website for programming in general, stackoverflow.com. It's like a forum where basically people ask questions, and people who know better than you will try to answer them. So this website is super valuable. If you ever have questions on coding and I can't answer them, or if it's for another class or something, I would recommend coming on here. Don't come on here just to get people to do your homework for you, because one, you don't learn that way, and two, people are kind of savvy about that, and they'll avoid doing that if you try it. So, but it's definitely a valuable resource, and it's definitely a place where you can ask questions once you've given it a shot yourself. So here we go. So this looks useful. This is the code that I've seen before. So we're going to do plot x, y the way we typically do, and then color, and then we're going to do random C. So this random c is equal to um, a random vector of 3 numbers. So let me go over this random command for you. So random, just by itself, just rand, will give you a random number. I think it's always between 0 and 1, but if for some reason you wanted a random number between 1 and 10, then you can do rand times 10, and there you go, right? So it's a random number each time, and if you want a vector of random numbers, then you tell it the size of the vector you want. So I typed in rand 1 comma 3. It's going to give me a vector of random numbers that's 1 row and 3 columns. So if I did rand 2 comma 1, it'll give me 2 rows and 1 column of random numbers from 0 to 1. And again, you can do the trick where you multiply by 10 if you want it between 1 and 10, or whatever. So if we come in here, we have our semilog xy, do color, and then we'll do rand 1 comma 3. And I think the logic behind having a vector of 3 random numbers is that if you're thinking about like red, green, blue color maps, you have to define a value for red, for blue, for green to give you a final color. If that makes sense. If not, I mean, don't really worry about it. It's not an important point. Just know that if you do color rand 1 comma 3, it'll give you a random color for the color of the line that you're plotting. Okay, so just to recap our code, since I kind of got sidetracked with figuring out how to make a random color, let's go through it line by line. So here we define our x. This is going to be our independent variable for the function that we define, and the function is y down here. And we're defining 5 y functions with our for loop, right? Because it's looping through 5 numbers, and each time y is going to change. Y is going to become x, which is our x data here, to the a power, and a again is 1, 2, 3, 4, and 5. And then once we figured out what y is, we're going to plot it versus our x data, and each time we plot a new line, it's going to generate a random color. And we want to make sure that the plots don't overwrite each other, so we're going to type hold on. And then at the very end, we're going to make our legend. Let me copy the code actually from here with the labels. Like that. Except remember, we have just an x now at the beginning. So yeah, oh, and we need to label our x and y axes. We can give it a title too. And that's the same as before. Let's save this. Plotting better, let's say. And we'll clear our workspace and run this. And if we look at our figure, there we go. No, I think I left the figure open from last time, so let me rerun it. There we go. Okay, so now you can see each line is a different color. We got kind of unlucky because some of them kind of look like the same color. That might just be my screen actually. There we go. Yeah, they still kind of look, the same color. So you can run it again. Maybe you'll get luckier with the random numbers that you get. But there, at least they're distinguishable. So yeah, I think that covers for loops and plotting. Hopefully this helps you do the homework. I think the homework you're pretty much just plotting the same thing with some different values for the parameters in the equation that you're plotting. So I think this tutorial will have all the tools that you need to do that. You probably don't need to do a for loop. You can if you want. If you want to get fancy, you can include it. You can do it with a for loop. But that's totally not necessary. You can just plot them one by one if you want. Whichever you prefer. If you have any questions, please, again, feel free to email me. Come to office hours. They're Wednesday from 12 to 2 in Spencer 131B. Um, and yeah, I think that's it for the MATLAB tutorial. I did want to apologize. I got a note from somebody saying that they kind of felt frustrated with the first homework because I had said that it was easy, or I think that I tried to make it easy for you guys. And it's I'm sorry, it's not fair for me to say that because I've taken this material before, and I made the homework, so I know what the solution is, but maybe I might not have communicated it clearly, and this stuff is probably more unfamiliar for you guys than it is for me. So I didn't mean anything by calling it easy. All I was trying to say was that I wasn't trying to make the homework intentionally painful for you guys. That was my point. So I hope I didn't bother too many people with that. If I did, I'm sorry. But I hope these video tutorials are helpful enough to make up for it. So, yeah, let me know if you have any questions. Thanks. Bye. If I could end this thing. There we go.